Take another example on using reduction formula for integrals of the form cos raised to power n of x dx. Now we have the general format that we have been using, and the question says determine the reduction formula for integral of cos raised to power nx dx from limit of 0 to pi over 2. So all is saying that we have cos raised to power nx dx is equals to 1 over n cos n minus 1 of x multiplied by sine x plus n minus 1 over n of I n minus 2. Now, if we are considering the limit of 0 to pi over 2, then we have from here to here to 0 to pi over 2. So let's apply our limit. That's 1 over n cos n minus 1 of pi over 2 sine pi over 2. This is subtracted from the lower limit of 0, that's 1 over n cos n minus 1 of 0 multiplied by sine of 0, and this will be added to n minus 1 over n I n minus 2. Now cos pi over 2 is equals to 0, sine pi over 2 is equals to 1, sine 0 is equals to 0, and cos 0 is equals to 1. So applying these principles here, then we know that this and likewise this will nullify into 0. So we'll be left with n minus 1 over n I n minus 2, which is the integral of 0 to pi over 2 of cos nx dx. Now note that this same reduction formula is the same for integral of 0 to pi over 2 of sine raised to power nx dx. Okay, let's move to another line. Now we notice that this reduction formula are the same, and this is known as Wallis formula. Now, the question that we are asked to solve is integral of 0 to pi over 2 of cos raised to power 5 x dx. Now we have found an expression for this for cos raised to power n of x, and in this case n is equals to 5, so we have I5. So we substitute our value of n, that will give us 5 minus 1 over 5 of I5 minus 2, which is 4 over 5 I3. Then we now can evaluate I3, that will give us 3 minus 1 over 3 of I into 3 minus 2, and that will give us 2 over 3 I1. And likewise, we can evaluate I1. You know that I1, In is equals to the integral of cos raised to power nx dx. Therefore, I1 is equals to, this has a limit of 0 to pi over 2. I1 is equals to the integral of 0 of pi over 2 of cos x dx. Now this will be equals to sine x, applying the limit. So we have sine pi over 2 minus sine of 0. Sine pi over 2 is 1, and sine 0 is 0. Therefore, our I1 is equals to 1. So if I1 is equals to 1, Let's now evaluate I3. Therefore, I3 now will be equals to 2 over 3 I1, which is 2 over 3 into 1, which is 2 over 3. Then as well, we can also evaluate I5, as I5 is 4 over 5 I3, 4 over 5 I3, and 4 over 5 I3 will be 4 over 5 into 2 over 3, and I5 will be what? 8 over 15. Now, since our question is the integral of 0 to pi over 2 of cos raised to power 5x dx, and is the same thing as I5, and this will give us 8 over 15. So we have now been able to establish understanding on reduction formula ranging from x raised to power n exponential x to x raised to power n cos x, x raised to power n sin x, and likewise x sin raised to power n of x, and also cos raised to power n of x, all with respect to x.